Hello, this is the fourth video, setting up a name server for your public domain. In the previous video we saw how to configure dynamic DNS on your local network. This video will first set up a properly configured SOA record, then set up a record for NS hosts, and finally set up glue records. Setting up a name server for a public domain works the same way as setting up a DNS server for an internal host name, just with a few additional parts that we'll want to make sure are in good state. Now let's see how to proceed with it. Let's set up a name server for a public domain. Set up a properly configured SOA record. Set up a record for NS hosts. Set up glue records. Cool. Now we'll see the actual working process. The first step is to configure the start of authority SOA for your domain. The SOA provides basic information about the zone itself. It contains a number of fields including example.org, the zone, IN, class of the record, IN is internet, which you'll see for the majority of DNS records that you see, SOA, start of authority, ns1.example.org. This is the primary master DNS server for the zone, admin.example.org. This is the responsible party for the domain. This should be an email address with the @ character changed to a dot. So in this example, admin@example.org should be contactable. 20150811401. This is the serial number of the zone. This is a 32-bit integer, which should increment when the zone changes. If the primary DNS server is not configured to notify slaves of changes, the slaves will automatically perform a zone transfer when this value increases. Using a numeric date for the serial is a common practice. 28800. This is the refresh period. It defines how often a slave should contact the master in order to check for updates of the serial number. You might see warnings if this value is less than 20 minutes or greater than 12 hours. 3600. Retry period. If a slave server cannot contact its master, how often should it retry? 604800. Expire period. If retries have failed beyond this period of time, the slave server will stop acting as an authority for the domain. 38400. This is the minimum or default TTL value. According to the RFC, this defines the lowest possible TTL value for a record in the zone. In practice, most DNS server implementations treat this as the default TTL value for records which do not set it explicitly. The next two items define the same information in two separate places. NS records point to the A record for the DNS server, which is authoritative for the zone. For example, ns1.example.org is authoritative for the example.org zone. That, however, leaves a bootstrapping problem in which the A record for ns1.example.org is defined within the example.org zone file. The solution for this bootstrapping issue is to use glue records. Glue records are stub records that exist at the point of delegation and define NS records for a zone as well as their matching A records. These values will be overridden by the records provided by the zone itself. A good example of glue records comes when you register a domain. In our example domain, example.org is delegated by the .org DNS infrastructure. Your domain registrar should provide you with a mechanism to add NS records and their matching A records on the .org servers. Since the glue records are managed outside of your zone, they're very easy to neglect when updating your DNS infrastructure. If your name servers are changing, you'll want to change them in the zone, as well as in the glue records. Nice! In this video, we dealt with setting up a name server for your public domain. In our next video, we'll be setting up a slave name server.